All right, so let's continue this problem. All we have to do now is set up the two equations and the two unknowns. So let's go ahead and write expressions for these two loops here. For one, it'll be starting here, and I'm going to go clockwise, right, with I1. So I'll say 12 angle 0 volts minus I1 times negative J4 is going to give me a plus I1 times J4. Then I've got a minus I1 times J5. All right. And then I've got a plus J3 times I2, right? I'm going across a voltage source here, and that equivalent voltage is J3 times I2. So I got plus J3 times I2. Again, it's plus because I'm going from the minus side to the plus side, so I'm going up in voltage. So I write a plus sign, and then that's equal to 0. That whole sum is equal to 0. So that's my first expression. Now we can write a KVL loop for the second. Let's start here and just go this way. So I'm going from minus to plus across a voltage source. So I'm going up in voltage. So I'm going to write plus J3 times I1. Okay. And then I've got a drop across the J6. So it's going to be minus I2 times J6. And lastly, a drop across the 12 ohms, which is just going to be minus 12 times I2. All right, so I've got my two equations of my two unknowns here. I can solve for one of these. Let's solve for I2, and then we'll plug that into the first expression, and we should be able to solve this this mesh analysis problem pretty easily. So it's going to be J3 times I1 is going to be equal to I2 times J6, basically 12 plus J6. Hopefully you see that. I basically move these terms over to the other side. They're both positive. Factor out an I2. And I want to solve for I2. So I get that I2 is equal to I1 multiplied by, and it's going to be basically J3 divided by 12 plus J6. And that's going to be, let's throw that into my calculator and see what comes out. Divided by 12 plus 6i here. Something doesn't seem right. Yeah, I was going to say I did something wrong for sure. Okay, good. There it is. So I get 0.1 plus J 0.2, and that's multiplied by I1. So that's my value for I2. And so now I can go and plug that into my first expression, right, using substitution. I can plug this in here. So let's go rewrite equation 1. It's going to be 12. I'll just write 12 instead of 12 angle 0. You should know now that this converts to 12 plus J0 in rectangular. So I'm just going to write 12. And then I'm going to factor out an I1. And I get J4 minus J5. So I just get minus J1. So actually, let's just write that as minus J times I1. Right? And then I get plus J3 times this expression here, which is 0.1 plus J 0.2 times I1. That whole thing equals 0. And now I should be able to pretty easily solve for I1 here, right? So I got 12, then I've got a minus J times I1, and then I've got a plus J 0.3, and then I've got a minus J 0.6 times I1, and that whole thing's equal to 0. Okay, so 12 plus J 0.3 is going to be equal to I1 times J, basically 0.6J plus 1J gives me J 1.6. All right, and now I just need to divide both sides by J 1.6 here. And I'll get my expression for I1. So let's see what that gives me. 12 plus basically 0.3 times I. And I divide by 1.6 times I. I get 0.1875 minus J 7.5. This doesn't sound great, but let me just throw this into my calculator and see what the phasor comes out to and see if it matches for I1. Yeah, something probably went wrong. I must have made a mistake somewhere. I1 is equal to 7.5 angle negative 88.56 degrees amps. Either I made a mistake or the book made a mistake, and I think it's probably more likely that it was me.